This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 128, the ins and outs of meshing with Ansys LS-DYNA, and a look at news and events from around the world of Ansys. Welcome. I'm Eric Miller, one of PADT's 3 owners and your host for these podcasts. Apologies for missing June. I want to blame the heat or something else, but in all honesty, the month just got away from us and we have so much going on, I just missed it. So here in Phoenix, we're hunkering down with temperatures over 110 that should last through the month of July, if not longer. That's 43.3 degrees Celsius. Speaking of weather, I do want to reach out to any of our listeners in Houston or nearby. We have 3 employees in the Houston area, and they've been struggling with power outages and unfortunately, or fortunately, only minor damages to their homes. But this first storm of the season flipped a lot of people for a loop, including many current and former employees of Ansys who live in the area. So we know a lot of folks that have been impacted. So we hope everyone got through this. And by the time you listen to this episode, your power is back and things have returned to whatever normal is these days. So really thoughts out to everybody there. And so also, a little bit of a reminder, it's engineers and scientists like those of you listening to this podcast. Some of those engineers and scientists use Ansys products and they work to predict these storms. Simulation is an important tool in weather prediction as well as to help give warnings. And then also in the area of creating structures and machinery and infrastructure that either lessens the impact of these storms or helps us deal with the aftermath of these storms. So, what we do is important in a lot of different ways, and this is an example of how technology that Ansys enables can be used, or technology similar to what Ansys does can be used to predict these storms and then to deal with them in the aftermath, and hopefully make the structures and things that we live and work in stronger, as well as we've been doing a lot of water management simulation for whatever reason recently. And so even the point of how we manage water in these places that deal with severe storms. So a shout out to everybody that works in the industry, the simulation world, to kind of help with these things. So let's dive right into our discussion. We're going to be talking to our chief engineer for simulation, Mr. Jim Peters, on meshing these days for Ansys LS-DYNA. I want to welcome everybody here to a discussion with our chief simulation person, Jim Peters. Hey, Jim, how are you doing today?
I'm doing pretty good. Thank you.
So we're going to talk about meshing in LS-DYNA. And so a little bit of a confession, since I've had my management lobotomy, I don't think I've actually fired up LS-DYNA other than do a simple test case in a very long time. But back in the day, one of the reasons why I was good at it was I was really good at it as a hex mesher, and using various homemade tools as well as tools like ISIM CFD and then Ansys Mechanical, what is now Ansys Mechanical APDL, to create hex meshes very laboriously create hex meshes for LS-DYNA for things like bird strike and metal forming and things like that. The reason why we're having this discussion is that's not the painful art that it used to be. And I wanted to get Jim on the call to talk about where meshing is for LS-DYNA today. There's a lot of options, and kind of educate me and all of you listening in on where that stands. So, Jim, do you still cringe when people say meshing for LS-DYNA, or is it now kind of we can do that?
Yeah, it's still the preferred method is to use topology, and obviously certain topologies lend themselves to hex meshing a lot easier than others. But there's certainly a lot more tools available to handle more complex topology than there used to be. So, so yeah, I don't really cringe too much.
So yeah, because it used to be, that there were people, that's what they did for a living, right? Especially in the automotive industry, is they just sat in a giant room and made meshes of cars, right, for months. Maybe we'll back up a little bit. And if I remember correctly, the whole reason why is the formulation in the explicit solver. If the elements themselves were not well behaved, the problem would blow up. Is that really why we're driven towards that kind of topology?
Well, yeah, everything on the LS-DYNA explicit side
Mm-hmm.
is reduced integration, and
Mm-hmm.
so a much simpler shape function, and so on one end it's much more robust to handle very large displacements because you only have a
Right.
single integration point.
Yep.
But on the other hand, it you know you don't get as good a derived quantities without having higher order type
Mm-hmm.
elements. So
Yep.
there's definitely a good mix of both, and that has been expanded both on the implicit and explicit side
Great.
to have high order hex as well as tet elements.
Great.
If you want. I mean,
If you want them. Yeah.
yeah.
Well, and the other thing, if I remember, is that because it's large deflection, you can get distorted elements, and then of course they no longer are valid. And so if you start with a somewhat distorted element, you end up with even more problems. It distorts sooner as you get your large deflection going. And then the other thing we'll talk about before we talk about meshing tools is element size. So again, on the explicit side, isn't the time step based upon the smallest element? And so you got to be kind of careful about that.
Yeah, it's a criteria that involves an edge length, the shortest edge length in an element, but it's also a function of density and speed of sound in the material. So modulus and density come into play to that time step as well. So the stiffer the material, the faster the sound moves through that material. So the time step has to be much smaller to accommodate that wave motion.
Because it's really the speed of sound in the element. Yeah. I forgot about that. Yeah, cool. It's fun stuff. So so if you needed to mesh something these days, what's your go-to tool to get started with?
Well, definitely with more complex topology, the Ansys suite, the meshing suite of tools that resides within the Workbench environment is really kind of the go-to method, just because there's so many different options now that can be used to produce some pretty good quality hex meshes and so forth. So, especially.
Go ahead. No, you go ahead.
Yeah, especially in the latest releases, there's been quite a bit of new, options exposed to the user that weren't really there in the past.
Right. Right. So does it kind of still work the same way that I take my geometry and I break it into volumes that are 6-sided and then I mesh those, or does it automatically do that, or how's that work these days?
Yeah, the mesh method, the multi-zone is really kind of the most robust one. That's the one that's really based on some of the technology of the ISM blocking meshing. And so a lot of the enhancements in the later releases have been to be able to automatically decompose those without you having to manually do it. So there's much less, slicing and dicing. I mean, there are situations where it just needs to be done in order to get a good mesh, but much less than it used to be. The tools are getting better to be able to accommodate some more difficult, surfaces that need to be, maybe extruded in a certain way based on that topology. So.
Okay, good. Yeah, that's really good to hear. And I forgot about that term slice and dice. That's what we used to do, right? And we would chop it up in the CAD side and then import the geometry and mesh it. Yeah, very cool that's come a long way. So what about in the LS-DYNA suite, the Ansys LS-DYNA suite itself? There used to be a mesher there. Is that still around? Is it something you use, or has that been migrated, or?
Yeah. The LS pre-post tool is one of those tools that comes as free of charge with the purchase of an LS-DYNA license, and that has some very nice solid meshing capabilities for primitive shapes like spheres and things like that. It's already kind of predetermined to give you a very high quality hex meshes out of that. And then, there are some techniques to be able to get some simpler geometry to be able to hex mesh nicely there.
Okay.
But the feature that's nice in LS Prepost that has just been recently exposed in Workbench is the ability to be able to use faces of shells or solids to extrude or revolve into new elements. So that's one that I use LS Prepost for a lot, especially on existing models that I may not have any geometry for, that I need to make some modifications. I can always take faces and extrude and create new parts or just add on to an existing part.
Gotcha. That's very handy. Yeah. So that's cool. Now, does space claim, again, I may be showing my lack of involvement in the day-to-day things these days, but does space claim have some meshing capability now? I know they were working on that. Is that there now? Or it's still coming?
Yeah, it's been in work for several years. It is available. It's not on by default, but there is an option menu to turn on that capability. And that's probably more in the style of a pure ISOM kind of approach where, in my experience, it does really well on single parts, very complex topology, single parts, assemblies, things like that. Maybe not quite as well, but there are some features with that particular tool that you can do some pretty amazing stuff. It's kind of its own little study all by itself. But if you really, really need to have a hex mesh on a piece of topology, really top level, what its features that allow it to do something really nice is the ability to be able to do sweep and mapping of faces simultaneously, because there's just some topology that if you sweep it, you get really tiny triangles near the center. If you map it, you can have uniform elements. But that particular tool kind of gives you the best of both worlds, being able to use both methods to kind of, sweep sections of it that are sweepable and then map other areas.
Okay. Yeah, good. And of course, you can also do that slicing and dicing, the CAD slicing and dicing if you need to in there, right? In Space Claim. Yeah.
Yeah, that's right.
Yeah, cool. And then, I guess, again, I'm showing my age here, but you do all your pre-processing these days in Ansys Mechanical, right? You don't like punch out a .k file. So those who don't know, a .k file is a text file that the solver reads into prep post and then modify it, or do you do everything in Mechanical these days?
Well, it's a combination of both. I'd say most of the time it's a hybrid. Most of the activity that I'm doing in the Workbench environment is geometry prep and meshing and, some boundary condition setups and so forth. There is quite a bit that's being supported each release. There's more and more supported. So, more of it can be done within that interface. But, there's just certain features and options that, are just a little bit easier to handle external. So,
get into the nitty gritty stuff that's not supported yet. Yeah. Okay, cool. And then, so is there a tool that you recommend that we haven't talked about? So we talked about Space Claim, we talked about the stuff in the Ansys meshing module, we talked about Ansys LS-DYNA prep post. Is there anything else that people should be aware of?
Well, I know there's other third-party tools that, especially in the automotive sector, that are using those. I see those through tech support, but I don't have access to using those. So, I can see there's some nice features in third-party tools, and obviously those tools have to work hard to keep their market share. So they're doing so. So, kudos to what they do, but, within the Ansys environment, like I say, I think most of the time I'm in the Ansys meshing tools to get most of my models prepped together. Okay. And that actually includes, particle methods as well. I mean, that's one of the new features that's part of the Ansys meshing is that, it used to be you had to create a donor mesh, and then you would take the donor mesh and that would be converted into particles based on the CG of the individual elements.
Gotcha.
And that's how you create a particle mesh. But now particle meshes can be generated directly on the geometry within the Workbench environment.
Good point.
And so, that's a tremendous capability there. Along with the capability of being able to use geometry to fill, especially if you're using ALE methods,
right?
Where you need to put geometry within cells that would represent either explosive materials or other materials within an air or a water domain. The ability to be able to fill a cell with a geometry reference is a really nice capability that's been added into that Workbench environment. So that saves a lot of effort that you could do manually before, but it's definitely much easier to do today.
You kind of had to trick it. Yeah. And that's a good point. Because I focus on the structural nonlinearity, the large deflection metal parts, but Ansys LS-DYNA does explosions, it does fluids, I think it does electromagnetics, it does particles. So there's more to meshing than just a mesh of a physical part. There's the air and there's the fields and all that stuff. So, or the fluids and the fields and things. So very cool. Yeah. So I guess to finish things up, if an engineer has been tasked with doing their first LS-DYNA model, and hopefully they weren't given like an entire car, front bumper, but something reasonable, maybe metal forming or a turbine blade or a fan blade or something like that, relatively digestible geometry. What advice would you give them to get started on meshing?
Well, it kind of depends on, what kind of physics, what kind of application is there, because there's, we've just kind of briefly talked about the particle methods, but there's a lot of particle methods that are very applicable to structural applications that provide the ability to model, element failure and erosion much more accurately than maybe a pure Lagrangian approach.
Okay.
The Lagrangian approach, if an element reaches a failure specification, it's removed, and you could keep the mass around. But one of the latest developments is embedding SPH particles inside of Lagrangian elements. So once they fail, those SPH elements become active, and so they can be coupled directly to that element so that they maintain all of the environmental, temperature and everything associated with that, or they could just be represented as debris. They have the right mass of the element that was removed, but there's no mass loss, and they can start interacting with other pieces of the structure, which can affect the way the failure mechanism behaves that way. So there's some really cool. Hybrid technologies that have been developed.
That reminds me, I don't know if you've seen it yet, but we are going to be doing a proposal for just that, for an application for a customer that wants to model the particles that come off during their event. So I can't say more. It's pretty cool application of that. So I mean, should they kind of map it out in their head, or just kind of dive in with the mechanical products and then use the other products if they need more capability? What's a good starting point? Let's just assume they're going to do a structural high deformation metal type problem.
Yeah, well, the biggest thing is, again, understanding the type of application, what features are important to capture in the model? What kind of results are you looking for? That's certainly the first one to help gauge what resolution a model, should I model as a shell, a thick shell, or a solid? It all depends on the type of model you're doing. LS-DYNA in terms of contact, has a beautiful algorithm to automatically, it's expensive at times, but you can basically with one contact card handle all possible contacts of all parts. Yeah. So setting up a model is significantly, in some aspects much faster than maybe a regular implicit run would be. But I guess the biggest guidance is just trying to pick the right element formulations that satisfy the type of results that you're looking for, and making sure that you're including the right material models and so forth to capture the behavior that you're trying to do. So, you can spend a lot of effort making a pretty model and use all linear properties and then not understand why it doesn't erode.
Exactly. And sometimes a part is just there for mass and momentum. And sometimes it's a target. Sometimes it's there for something else to hit. And sometimes it's the part you really care about and you want to know what the stresses are and the failures are and things like that. Yeah. Good point. Good point. Yeah. Well, very informative. And I'm so glad that younger engineers don't have to suffer through what we did back in the day. Couple that with the faster solvers and faster computers to run on. That's why, and all the multi-physics capability in Ansys LS-DYNA, it's really come an amazing long way from that government code I used 45 years ago?
Some time ago, yes.
Can't remember. This is like in the early 90s or late 80s. Fantastic. Thanks always for your time, Jim. Very helpful. Sure. Your years of experience on this stuff, and hopefully it'll help people get started and help them save a little bit of time and a little bit of effort and dive right in and create that mesh and get those results.
That's right.
Yeah. All right. Thanks, Jim.
Good. All right. You're welcome.
Talk soon. Bye.
Bye.
Welcome back. So really the bottom line for me is we have so many more options these days than we used to get the mesh we need for this amazing solver. And this solver does so much more, as do the meshers. The days of spending weeks or months handcrafting a mesh are almost gone. We don't cringe when we need to do one of those. And I think the robustness of the solver is improved as well, so they can handle the mesh doesn't have to be quite so perfect these days. So all good things. And hopefully you all found that useful, and we'll jump right into using, as we said, using LS-DYNA more on different problems. If you're struggling with your Ansys LS-DYNA mesh or want to learn more about why we get so excited, and one of the things Jim said after the podcast was, LS-DYNA is my favorite tool, and we do, and it's really one of our favorite tools around here. So when we talk about Ansys LS-DYNA, we get really excited, and if you want to understand why we think it's such a great tool, please reach out to PADT. Let's talk. When that really leads us right into our commercial for this episode, I want to talk about PADT as a whole. So we're a 95-person company based here in Tempe, Arizona, with offices across the Southwest. And as I mentioned, people across the Southwest. We have folks now in upstate New York and in South Carolina, several people in Texas, including the 3 in Houston. So we're kind of all over the place in Idaho, Nevada, Colorado, New Mexico, California. So all those different places. I'm sure I'm leaving somebody out. But anyway, that's not the point of this commercial. We're basically the Southwest leading provider of products and services for companies that design and manufacture products. So we started the company back in 1994. In fact, our 30th anniversary was a few months ago. And we took 3 core, what we at the time called computer-aided engineering technologies that we were using at what was then called Allied Signal Engines, which is now Honeywell, and built a consulting firm around them. We did simulation, we did advanced design, and we did what we now call 3D printing. We called it rapid prototyping back then. A few years in, the vendors who we were providing, who were, basically giving us the tools we were using to build this company, asked us to become resellers. And that's how we became an Ansys reseller, and a Stratasys, Flownex, et cetera. And it's been fantastic. We added Flownex to that. We added EOS metal 3D printers and the scanning technology from Zeiss. So lots of things that we sell. And we continue to provide services as well. So we have teams dedicated to doing product development, design and test and R&D and project management. We, of course, have a simulation team that uses the Ansys tools however you need help. And we have 3D printing as a service, having all the leading technologies here in-house. So you can learn more about all the different things we do at www.padtinc.com. Most of you who are listening to this podcast probably know us for Ansys, which is great, but we do a lot more. So please, recommend us to other people you work with in your own company, or friends of yours, or people in other companies that need help with their mechanical engineering, no matter what it is. Not just simulation, but how we can help you with design and 3D printing and all those sort of things. So. And also, if you want to talk to us about your tools, your simulation tools, your 3D printing tools, et cetera, your scanning tools, reach out as well. And you just go to our site, padtinc.com, and click on the contact button. And there's all sorts of ways to get hold of us. You can send us an email, you can call us, you can fill out a form. We promise to have a technical person reach back to you, and you won't be hounded by a salesperson all the time. So please do reach out. We'd love to help you however we can, with Ansys if possible, but and doing simulation if possible, but we do a lot more here. All right, let's jump into the news. The Ansys stock, it's still bumping around. Today is the, July 10th. It's at $329. It's been, plus or minus, $5 or $10 a share for quite some time now. It's still below the $390 offer that Synopsys made to them. Meanwhile, of course, the S&P 500 is at an all-time record high. Ansys is actually down year to date because we kind of had a peak there at the beginning of the year because of the rumors of the takeover or the merger. Don't use the term to take over. It's a merger. And Ansys is down 6.67% for the year because of the pending merger. But the S&P 500 is up 18.3%. So, we really can't, read a lot into the Ansys stock price because it's not really out on the market, right? There's a price out there for it. And as I said, that's all for July 10th when I'm recording this. Some news. Just yesterday, Ansys announced that the Ansys STK, which is their satellite toolkit, is available on AWS Marketplace for use on AWS GovCloud. So if you don't know what STK is, it's a mission simulation tool. Most people use it to do like satellites in orbit, but it can be used for airplanes and cars and pretty much anything that moves around in the greater world. You can simulate it with that tool. And you can do your mission modeling now on a secure government cloud resource. So pretty nice. 100% run in the cloud now with Ansys STK. And it's available, as I said, in their marketplace for GovCloud. So check that out if you're looking to use STK and don't have the horsepower in-house or need some surge horsepower. Two other stories, I won't go into details on the stories, but they're about, and this has been a trend for several months, if not years now, is they're about how a producer of a certain semiconductor technology, say, I think in this case, it is Samsung and Intel, right? They have certain chip technologies that they can make chips for other people using their foundries or in-house for their own chips. And they've now standardized on Ansys technology, or Ansys is working on the standard for doing some form of simulation to do what they call, to evaluate those chips and make sure that they're okay. It's called sign-off in that industry. And I bring it up because I know most of our users aren't users of the Ansys semiconductor technology, but if you're wondering why Synopsys is interested in merging with Ansys, this is why. It's the standardization on Ansys multiphysics technology in the semiconductor industry that is so attractive to Synopsys, which has a lot of tools in that industry. So, and all the stuff that we do with mechanical and fluids and all that is beneficial as well. But in my very unprofessional and I don't understand stock market opinion, I think it's these announcements of Ansys being standard. It's really driving that merger. So also speaking of cloud, speaking of that merger, in May, right after the last podcast, I think it was the 22nd or something like that, Ansys stockholders officially voted and approved the transaction with Synopsys. So the stockholders have given their approval to this transaction. I think it was like over 80% of the stockholders that voted decided to go forward with the transaction, which is fantastic. So that doesn't really change the close date, which is the first half of 2025, and it doesn't change the fact that there's still regulatory approval pending. So there's a lot of work still going on. So we'll keep watching that. We hear nothing. If you spent time around Ansys or the Ansys world as intimately as we do, you wouldn't think there was going to be a merger. So they're really following those rules quite closely, which is kind of nice to see. And then also speaking of cloud, so we started with a cloud story, and we're going to finish with a piece of Ansys news in the cloud. Ansys and Microsoft announced Ansys Access on Microsoft Azure via Azure Marketplace. And what that means is you can get access to Ansys tools using the standard Microsoft Azure platform, which is really kind of cool. This is a more accessible and new way to get access and run Ansys in the Azure cloud. So if you are one of those people that's got a lot of Azure credits, or you really like running on Azure, it's your preferred platform. There's a lot of different options for cloud, but a lot of people do like that platform. It's just easier now. So check that article out. Those are all different articles if you go to the Ansys News website. What about over on PADT news? We actually have some. Usually I'm like, we don't have any news, but this time we do. First one is, it's not quite public yet, but I'll let you guys know. We did a soft launch of a new website called 3D Printing Factory. So as I mentioned in our commercial today, PADT's been doing 3D printing for 30 years now, right? And my co-founder, Ray, has been doing it for longer than that. And it was always a little confusing when you go to our website. You see the Ansys stuff, and you see the sales stuff, and you see the design stuff. And so we wanted to really focus on 3D printing for our customers that do just that with us. So we created a separate site called 3D Printing Factory for them to go to. You can upload your files, request a quote, and we'll be adding more features to that as time goes by. So it joins our material purchasing. If you're a Stratasys user, you can buy material from us there, as well as our standard website that talks about all the different things we did, which I covered in the commercial today. Another piece of news is if you've ever listened to one of our webinars, we are moving from the BrightTalk platform, which we've been using for many years now, but we've really kind of outgrown it, and it's kind of drifted in a different direction than we're headed. So we're going to pull all those, the ones that are still relevant. We won't keep the update for Ansys, 2017. We'll have the more, the ones that are still have value today. We're going to move those over onto our website, the PADTinc.com website, and we'll be hosting webinars in the Microsoft Teams new webinar tool. So most of you probably use Teams or use Zoom. It's very similar to the Zoom webinar tool. So you'll do registration through that now, and we'll do the recording through that and the questions and answers and everything. So we'll be moving to that platform, if not this month, next month. So do look for an invite to that, and all of those old seminars or webinars will be available as well. So if you go to our website in a couple weeks, PADTinc.com/webinars, you'll be able to see everything there. So let's talk about blog articles. Ansys, if you're a new listener, you should know that I try to pick out 3 blog posts that Ansys has done that are fairly technical and informative and interesting. And so my favorites for this episode are, the first one is that they've launched a new online help site. So if you've been a long-term Ansys user, you know that it started with manuals, and then we had PDF files, and it was also built into a custom application that ran on the desktop, and there was an online version that was available through a particular login. Well, now that online version is available to everybody in the world, and the main reason is that it's now available through search engines. So you don't have to go to the Ansys help and then search. You can search for something, and the Ansys help answer will show up in the general search, which is kind of a cool thing. Now you may the article's called, what's it called here? It's called Get the Ansys Help You Need When You Need It. And it starts off with kind of a cool history of the documentation of how Ansys documentation has been done in the past. And in fact, we still have some of those paper copies in the big yellow binders with the Swanson logo on the side of them. It's kind of cool. And then they talk about how everything's changed, what is available on this public side. And then there are certain things that are proprietary that they don't want other people to know. And so those you still have to have a login to get to. And that'll all become clear as time goes by. But yeah, so help's moved. It's now available to the public and to general search, which is kind of a neat thing. My second pick, and I went kind of long on that because it's kind of important, but my second pick is how simulation addresses hydrogen fuel challenges. I always stick fuel cell in there. It's hydrogen fuel challenges. So it's about modeling the combustion of hydrogen, which is different than other fuels, using the Ansys suite of simulation tools. So very useful if you're burning hydrogen. Really cool, and found that very interesting. And then the last one is called Porsche Motorsport Races Towards Electrification with Simulation. And as we all know, racing pushes technology, and Porsche is leading the way with consumer vehicle electrification by really advancing their technology in racing, as they've done with other aspects of automotive over the years, decades. And Ansys plays an important role in how they are doing their electrification for racing. This also happens to be the 10th and last article of the series of content about Ansys in transportation world. It's called Driven by Simulation, and it's really cool articles. We've mentioned a couple on this podcast, but if you're into transportation of any kind and Ansys, definitely check it out. If you Google or use whatever search engine you like, Driven by Simulation, and then add the word Ansys on the end, it'll take you to the website where they've got all 10 of them listed. So it's a good read, very good read, very interesting stuff. On the PADT blog side, we've been actually, one of the good things about missing the podcast is we had a lot of posts go up. Our engineers have been really busy, so we actually had 6 go up since the last podcast. The first one is called FlowNext version control with Git client. So, you can do your management of the different versions of your model. You could always use Git to do the software, the customization of FlowNext, but now you can actually manage your different runs, your different models, your different permutations using the Git Git tool. If you don't know what that is, check out the article. It's kind of a cool open source tool to manage data. So really nice there. The next one is something that I wrote. I've been playing a lot with generative AI image generation. And so I wrote an article called Generative AI Image Generation for Engineers, a short Adobe Firefly tutorial. So I use Adobe Firefly for that stuff. Been very useful for me. Then Josh Stout wrote an article called RBF Morph, a journey of morphing on existing Ansys mechanical mesh into a target geometry. So this is about how you've got a mesh that's slightly distorted and you want to move that mesh to line up with a different mesh. Or maybe you've got an undistorted mesh and then you've got a distorted mesh and you want to take the temperatures from the distorted mesh and put it on the undistorted, whatever it is. This allows you to do that morphing quite easily. It's a pretty cool tool called RBF Morph, which is an Ansys partner. Then Miles also wrote an article about Independence Day brisket analysis. So he basically was barbecuing in the backyard and used FlowNext to model it. So kind of fun and interesting. I really like that one. Then Alex did one of his great articles. This one is called Thin Wall Rectangular Pressure Vessel Simulation. So, most pressure vessels are round for a reason. They don't have the stress concentrations in the corners, and et cetera. So he really goes into how to model that. It's not as straightforward as you would think. So pretty cool stuff, and how to approximate it, how to do hand calcs, as well as how to do a detailed nonlinear simulation. And then we finished up the month. It'll come out actually tomorrow after this podcast gets released, hopefully, or in the same day that it's released, called 3 Methods for Applying a Spatially Varying Heat Flux in Ansys Mechanical. And this is Bronislaw Piak. And so what he did is he took some other articles that he and others have written over the years about how to apply heat flux in Ansys Mechanical, and kind of talks about how to do the 3 different ways to do that. It's a nice summary article and gets in kind of in depth of how to use the different methods, which I won't share. You got to read the article to find out. So that's it. Like I said, we've been really busy with blogs. And then let me check out our upcoming events. We don't have a webinar scheduled right now because we're getting the new Microsoft platform up and running, but we'll have that within a couple of weeks, if not a month. But as far as events go, if you're listening to this before July 12th, I will be down along with some other folks from PADT at the Arizona Technology Council's 12th Annual Aerospace Aviation Defense and Manufacturing Conference. A lot of our customers that use Ansys in the aerospace industry will be there and on panels with us. I'm going to be doing a panel on manufacturing. And then on the 15th, a group of us will be in Salt Lake City for the Experience Stratasys truck tour. You don't have to be interested in 3D printing to stop by and say hi. So we're going to be at Miller Advanced Research and Solutions Center, which is in Clearfield, Utah. And you can check out our website to get more info on what that is. And then a few days later, we'll be heading over to something called Stratafest, which is another Stratasys event. This is basically a Stratasys user group meeting rather than here's the machines. It's a user group meeting. It's going to be in Denver this year at the Wings Over the Rockies Air and Space Museum. Great event. Stratafest Denver. Really highly recommend you check it out, even if you're not a heavy user of 3D printing. That's pretty much it for July. In August, we just have one event right now on the calendar. For the Arizona Technology Council, we'll be going up to Sedona again for the CEO Leadership Retreat. Looking forward to that. Kind of get out of the valley and spend some time with technology leaders from Arizona. It's always one of my favorite events of the year. So if you're a technology leader listening to this, please check that out and come up and join us. On the 9th, we're going to be of September. Moving on to September now, we're going to be at the Turbine Engine Technology Symposium. We're going to have a booth there. The Flownex team is going to be there. We're going to be talking about using Ansys and Flownex for turbo machinery simulation. On the 10th, I'll be at the 10th of September, I'll be at the New Mexico Tech Summit for 2024, which is going to be at Albuquerque again. Love that event. Met a lot of folks there from the labs as well as other companies around New Mexico. So it's always a fun event. Enjoy that, and maybe the New Mexico food as well. And then on the 23rd, don't forget that we've got Nerdtoberfest coming up. So that's a really important celebration of our 30th anniversary. As well as our annual open house. So if you're anywhere near Tempe, Arizona, in October 23rd, please come by for our open house. And then the other event that for some reason is not showing up on the calendar, I'll be at the Rocky Mountain Investor Conference in somewhere in the Rocky Mountains. I can't remember which town it's in this year. I think on the 11th and 12th, or the 12th and the 13th of September. So that's a fun event. Always enjoy going to. So lots going on. I'm sure we'll fill in more as time goes by. Really appreciate your time with the podcast. I'm going to also make a little request before we sign off. You know, our listenership, I guess is the right term, has been going up slowly but surely. But we'd like to see more people listen. I think that a lot of people would enjoy this podcast, but if they don't know about it, they may not be listening. So if you could tell a friend, share us on social media. You know, if you like this podcast, just let people know that you'll listen to the Ansys, All Things Ansys podcast from PADT, and just put it out there on social media and let folks know. And let's try and get a few hundred more listeners every episode and spread the joy and fun of being an Ansys user out there. So don't forget to subscribe to our newsletter as well, where you can learn a lot more about what we do here and what our customers are up to at padtinc.com/opt-in. And do, like I said, let people know about the podcast. And as always, don't hesitate to reach out if you have any questions or suggestions. Thanks a lot. Thank you for joining us for the All Things Ansys podcast, episode 128. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, please visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.